What is going on, everybody? I got another video here for you. This is for an applied calculus class, and it's McClaurin Seris. All right, so the McClaurin Seris. So if you've got a function f of x, we can write this as a McClaurin Seris, and the way that we do it is we have f of x is equal to f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial. And then we've got f triple prime of 0 times x cubed over 3 factorial all the way to the nth derivative of 0. We evaluate the nth derivative of 0 times x to the n over n factorial, where n factorial is n times n minus 1 times n minus 2 all the way down to 3, 2, 1. So an example of factorial, so if you have 5 factorial, well, that's equal to 5 times 4 times 3 times 2 times 1, which that would be 120. Or if you had 3 factorial, that's 3 times 2 times 1, which is 6, and so on. That's what factorial is. All right, so basically all we're going to do is we got some examples to work. I think we got 4 examples to do. All right, so find the first 4 terms of the McClaurin series. All right. So to do this, well, we've got f of x. So remember, it tells you the first 4 terms. So we've got 1, 2, 3, 4 terms. So we've got to go all the way to the 3rd derivative, okay? So the first thing I would do is probably write this f of x is 2 times 2 minus x to the negative 1. And just use the chain rule to find the derivatives. So we've got f prime of x is equal to negative 2 times 2 minus x to the negative 2 times negative 1. Okay, so remember chain rule, the negative 1 comes down, negative 1 times 2 is negative 2, subtract 1, that's minus 2, times the derivative of what's inside the parentheses. Derivative of this is negative 1. And so this would be f prime of x is equal to, and that's going to be 2 times 2 minus x to the negative 2, which is 2 over 2 minus x squared. And when you take the derivative, leave it in this form to take the derivative, but go ahead and write it like this because it's going to be easier to evaluate when it's like this versus being like this. And so then we have f double prime of x. So I'm going to use this to take the derivative. That's negative 4 times 2 minus x to the negative 3 times negative 1. And so that's going to be f double prime of x is equal to 4 times 2 minus x to the negative 3, which is 4 over 2 minus x cubed. All right. All right, and then the 3rd derivative, let's see. So the 3rd derivative, f triple prime of x is equal to, we'll use this, so that's going to be negative 12 times 2 minus x to the negative 4 times the derivative of what's inside the parentheses. So f triple prime of x is equal to 12 times 2 minus x to the negative 4, which is 12 over 2 minus x to the 4th. All right, so now, well, what do we have to do now? Now we have to evaluate each one of them at 0. Okay, so I've got f of 0 is equal to 2 over 2 minus 0, which is 1. F prime of 0. So I'm going to plug it into this one. that's going to be 2 over 2 minus 0 squared, which that's 2 over 4, which is 1/2. F double prime of 0, I'll plug into this one, which is 4 over 2 minus 0 cubed, so that's 4 over 8, so I guess that's 1/2. And then F triple prime of 0, that's going to be 12 over 2 minus 0 to the 4th, so that's 12 over 16, was that 3/4, I believe. All right, so now let's go ahead and let's select this and bring it on down. Come on. There we go. All right, so these are our values. So remember, our formula is f of x is equal to f of 0 plus f prime of 0 times x squared plus, times x, plus f double prime of 0 times x squared plus f triple prime of 0 times x cubed. Okay, and then plus ... Okay, we're finding the McClaurin series, and they just want us to show the first 4 terms. All right, and this should be over 2 factorial, and this is over 3 factorial. All right, so we have f of x is equal to, or, well, f of x, which in our case is 2 over 2 minus x. See, that's our f of x, 2 over 2 minus x. All right, and so that's going to be f of 0, which is 1, plus f prime of 0, which is 1/2 times x, plus, and then f double prime of 0 is 1/2. Now let me say this. I guess it doesn't matter. Let's just write it like this: 1/2 over 2 factorial. Now 2 factorial is what? 4 times x squared, plus, and then f triple prime is 3/4 f triple prime of 0 over 3 factorial, so that's 3 times 2 times 1, which is 6 times x cubed plus ... And so 1 plus 1/2 x plus, that's going to be 1/8 x squared plus, and then that is going to be, what is that? 3 over 8 x cubed plus ... And so this would be our McClaurin series. I believe, no, wait a minute, let's see. That's not going to be 3/8, that's going to be 1/8. And this, hang on, let me see something. Yep, I'm sorry. 2 factorial is 2. And so that should be 1/4. My bad. Sitting here trying to do all this in my head, so might make another mistake later on, but I will catch it and fix it. All right. So there's your answer there. All right, let's look at the next one. Find the first 4 terms of the McClaurin series expansion of this. All right, so we got to go to the third derivative again. So I get f prime of x is equal to, well, that's e to the negative x, and then times the derivative of the exponent. The derivative of the exponent is -1, so that's going to be negative. F double prime of x, well, the derivative of e to the negative x is e to the negative x times the derivative of the exponent, which is -1. Okay, well, let's just write this one out. Okay, so I got negative derivative e to the negative x is e to the negative x times the derivative of the exponent, which is negative 1 and a negative. That's going to be positive. Okay. All right, and then I have f triple prime of x. Well, that's just negative e to the negative x, and that's it. All right, so now we've got to do f of 0 is equal to e to the negative 0, which is 1. F prime of 0 is negative e to the negative 0, which is negative 1. F double prime of 0 is e to the negative 0, which is 1. And f triple prime of 0 is negative e to the negative 0, which is negative 1. And then we'll write the formula out. That's going to be f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared plus f triple prime of 0 x cubed. And this is over 2 factorial, and this one's over 3 factorial plus, okay, and then it keeps going. But they just want us to show the first 4 terms. All right, so let's plug everything in. So I get e to the negative x is equal to f of 0, which is 1, plus f prime of 0. Well, f prime of 0 is negative 1, so that's going to be minus 1 times x plus f double prime of 0 is 1, so that's going to be 1 over 2 factorial, which is 2 times x squared, plus f triple prime, which is negative 1, so that's going to be minus 1 over 3 factorial, which is 6x cubed plus ... And that would be your answer. And then, you know, you would just rewrite it 1 minus, and then get rid of that 1 there, x. 1 times x is x, plus 1/2 x squared minus 1/6 x cubed plus ... And this would be your answer. All right, so, well, so far, problems aren't too bad. Okay, so let's look at this one. Find the first 3 non-zero terms of the McClaurin series expansion. All right, so how many derivatives do we need to take? Well, I don't know. Let's look. So let's go ahead and do f prime of x is, so the derivative of sine is cosine 2x times the derivative of what you're taking the sine of, which is 2. And then f double prime of x is equal to, well, the derivative of cosine is negative sine. Okay, let's just write this one out. So that's 2 times negative sine 2x times the derivative of what you're taking the cosine of, which is 2. And so that's going to be f double prime is what? Negative 4 sine 2x. You see that? Negative 4 sine 2x. So let's just change that. Negative 4 sine 2x. F triple prime of x is equal to, well, derivative of sine is cosine times the 2 times derivative of what you're taking the sine of. So that's going to be negative 8 cosine 2x. And then the fourth derivative of x is, derivative of cosine is negative sine. So the negative and negative is going to make a positive, times, let's just come over here to the side and do it. So negative 8 cosine 2x. So the derivative of that is 8 sine 2x times derivative of what you're taking the sine of 2. So that's going to be 16 sine 2x. Now, let's look at this real quick. Let's just kind of see what we have. So remember, we're going to be plugging 0 in, and we want the first 3 non-zero terms. Well, remember, if I plug the 0 in here for x in the sine functions, that's going to give me 0 because the sine of 0 is 0. So right now I have 2 cosine functions. So I'm going to need to take a fifth derivative. So the fifth derivative, well, derivative of sine is cosine times 2 times the derivative of this. So that's going to be 32 cosine 2x. All right, so here we get f of 0 is sine of 2 times 0, which is 0. F prime of 0, which is 2 times cosine of 2 times 0. Well, cosine of 0 is 1, so 1 times 2 is 2. F double prime of 0, that's 0. F triple prime of 0, negative 8 times cosine 2 times 0 is negative 8. The fourth derivative evaluated at 0 is 16 times sine of 2 times 0, which is 0. And then the fifth derivative evaluated at 0 is 32 times cosine of 2 times 0, which is 32. All right, so there we have all of our values. So remember, f of x, so we're going all the way to the fifth derivative here. So that's going to be f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared plus f triple prime of 0 over 3 factorial times x cubed plus the fourth derivative evaluated at 0 over 4 factorial times x to the fourth plus the fifth derivative evaluated at 0 over 5 factorial times x to the fifth plus dot dot dot. All right, so let's plug everything in. And so I get sine 2x is equal to, all right, so f of 0 is 0. So that's going to be 0 plus, and then f prime at 0 is 2. So that's going to be 2 times x plus, and then the second derivative evaluated at 0 is 0. So that's going to be 0 over 2 factorial x squared plus, and then f triple prime, that's negative 8. That's going to be negative 8 over 3 factorial. 3 factorial is 6 times x cubed plus, and then the fourth derivative evaluated at 0 is 0 over 4 factorial times x to the fourth. I'm not worried about calculating those factorials because it's just going to go to 0. And then plus 32 over 5 factorial. And 5 factorial is 120 x to the fifth plus dot dot dot. And so we get sine 2x is equal to 2x minus, that's going to be what, 4/3 x cubed plus, and then let's see, 32 over 120. Let me get my calculator. 32 over 120, that is 4 over 15 x to the fifth plus dot, dot. And there's your McClaurin Seris expansion of the first 3 non-zero terms. Okay, and let me say this: if at any time during this video I said Taylor series, I didn't mean to. Okay, that's going to be the next video. So this is McClaurin Seris. All right, so let's look at this. It says a lever is attached to a spring Frictional forces in the spring are just sufficient so that the lever does not oscillate after being depressed. Such motion is called critically damped. The displacement y of the lever as a function of the time t for one such case is this: y equals 1 plus t times e to the negative t. In order to study the motion for small values of t, a polynomial form of y equals f of t is to be used. Find the first 4 non-zero terms of the expansion, and we're going to find the McClaurin series expansion. And here's a little diagram of it. This is your lever right here, and there's your spring, and so when you hit that lever, it's not gonna so the lever does not oscillate after being depressed. All right, so we've got y is equal, and I know it does say y. We'll just use y. That's 1 plus t e to the negative t. So this ought to be fun taking this derivative, shouldn't it? So let's see what we got. All right, so this, I think it's going to take more time finding the derivative here. Let's see, we got y prime is, now this is product rule. I got this function times this function. So it's the derivative of the first times the second plus the derivative of the second times the first. And so that's going to give me y prime is e to the negative t. And let's distribute minus e to the negative t times, well, plus e times plus t e to the negative t. So y prime is just t e to the negative t. There we go. So that wasn't bad. And I left off a negative. That would have been bad because it's the negative 1 here. These two go to 0. All right, now the second derivative. This is going to be product rule again. All right, and I think what I'm going to do is I am going to underline the ones that I'm going to be evaluating, because I think I'm going to have quite a list here. So this is going to be derivative of the first times the second plus the derivative of the second times the first times negative t. So y double prime is negative e to the negative t, and that's going to be plus t e to the negative t. All right, so we'll be using this one. Now, hopefully you get the idea. We're going to have to take the derivative of this and then the derivative and plus the derivative of this, and this is going to be product rule, just like what we did here. Okay, so I'm not going to go through working all that. We're just going to write these down. Y triple prime is equal to, so the third derivative is 2e to the negative t minus te to the negative t. Now, if you look at this, we've got 1, 2, 3, 4 terms here, okay? But notice what it says. It says first 4 non-zero terms. And look at this one. Remember, we have to evaluate each one of these at 0. So if we plug 0 into this one, that's going to be 0. Okay, so far the other ones won't be 0. So we're going to need to do one more derivative. So we'll need to do the fourth derivative. And that is going to be te to the negative t minus 3e to the negative t. So these are the ones that I'm going to use. Okay, I'm going to use these 1, 2, 3. Well, I'm not going to use this one. Well, I mean, I'll evaluate. We'll go ahead and evaluate it just to show you, it's 0. But those 5 we're going to evaluate. So I'm going to rewrite these down here so we can see everything, and I'll pause the video while I do that. All right, so we've got all the ones. We copied them down again of what we got to evaluate. So I've got y of 0 is equal to 1 plus 0 e to the negative 0, which we can see that's 1. Okay, and then we've got y prime of 0 is negative 0 e to the negative 0, which is 0. Y double prime of 0 is negative e to the negative 0 plus 0 e to the negative 0, so that's negative 1. And then y triple prime of 0 is 2e to the negative 0 minus 0e to the negative 0, which that's 2. And then the fourth derivative evaluated at 0 is equal to 0 times e to the negative t minus 3e to the negative 0, which is negative 3. All right, so let's write our formula down here. So f of x, f of t, y of t, I guess we'll write y of t because our variable is going to be in terms of t. So that's going to be y of 0 plus y prime of 0 times t plus y double prime of 0 over 2 factorial times t squared plus y triple prime of 0 over 3 factorial times t cubed plus the fourth derivative evaluated at 0 over 4 factorial times t to the fourth plus ... Okay. All right, so now we plug everything in. So we have 1 plus t e to the negative t is equal to, well, y of 0 is 1 plus y prime of 0, which is 0 times t, plus, and then y double prime, that's negative 1 over 2 t squared, 2 factorial is 2, plus, and then y triple prime is 2, so that's 2 over 3 factorial, that's 2 over 6 times t cubed. And then we've got plus, and then that's going to be negative 3 over 4 factorial. What is 4 factorial? 4 times, that's what, 24? T to the fourth plus ... And so now we've got 1, that goes to 0, minus 1/2 t squared plus 1/3 t cubed minus 1/8 t to the fourth plus ... And this would be your answer. All right. So not very difficult. You just got to know. You got to know the formula. What I would recommend is whatever you got to find, however many derivatives you have, just write this down. And then you're just like you're back in elementary school, plugging numbers in, plugging stuff in. Okay. All right. So I hope that video helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching. And I will see y'all in the next one. Later.